All right, this is the measurement video. So remember, in all of these videos, there's going to be two codes. There's going to be one is going to be a written code that will show up on the screen, and the other will be a verbal code said by myself. So each code will be 3 numbers. So you'll need all the codes in order to move on with the homework assignment. Right. So everything that you see in green should be in your notebook, right? You do get to use your notebooks on the quizzes every other Friday. Everything that's in green should be in your notebook. So these are the procedures in order to, if you miss a notebook check, there is a Google Forms for that. So right now, this is the written code. I would recommend you write this down. It is 382. So the written code is 382. All right. So the first thing we did was the metric versus English lab. So in this, we measured the diameter and circumference of 3 different cans. And we did it once with the English side, or those inches side, and once with the metric side. So what I wanted you to see in this is that the slope is going to be the same because we're taking the circumference divided by the diameter. And in each of those, the slope is going to be the circumference divided by the diameter, which is just pi. That's not going to change based on what type of measurement that we're using. So it doesn't matter what we're using, the English side or the metric side, you're still, the ratio of circumference to diameter is always going to be pi. But we're going to go over why we use the metric system in this class. So everything that we did in this notebook, or everything we did in the notebook, was going to go on page 7 today. So this is what that table, or this is what your table of contents or that index should look like. And everything, once you flip over, should be on this side. Remember, we write everything on the same side on page 7. So this is what we learned about the metric system, right? The metric system is used in science for 2 reasons. Number 1, it is universal. Everything is defined as constants of the universe. And also, it's base 10, so it's going to be easier to use. So think back to that black box experiment we did. There's no box of the universe to open up and say, hey, this is the measure, this is the universe, or this is the universal measurement system. We had to make our own, and we based them on constants of the universe. So in order to convert in the metric system, it's very easy. All you have to do is to convert within the metric system usually means just moving the decimal point. If you can remember what the prefixes mean, you can convert within the metric system relatively easily by simply multiplying or dividing the number by that value of the prefix. Or we can just use that chart. That's what we're going to be using in this class. So if I'm doing 1.5 kilograms converted to grams, you're going to have to look at the kilo, right? So that's going to be this one on the far left. That's 1,000. And it's asking to convert to grams. So grams is a basic unit, that one in the middle. So we're going to move the decimal point to the right, and then we count 1, 2, 3 times because we started on the kilogram and we're moving to that basic unit. So that's 3 spots, and we move the decimal point and we have to add those zeros, and we get 1,500 grams. Now, if we go the other way, 1,000 milliliters converted to liters, well, we start with the milli. That's all the way on the right. We're going to the liter, which is the basic unit. That's going to be that middle one. So now we're moving the decimal point to the left, 1, 2, 3 units, and we're going to get 1 liter. So now let's talk about length in the metric system. So length, we'll be using the meter stick to measure length. Now the basic unit of length in the metric system is the meter, represented by lowercase m. A meter is about the width of a doorway. So 1 millimeter is about the thickness of a dime. So 1/1000th of a meter. Now 1 centimeter is about the width of a large paper clip or your fingernail. So if you look at your fingernail going across, that is going to be 1 centimeter. A kilometer is about 6 city blocks or 10 football fields. So it's easy to visualize a football field and say, okay, well, if you walk 10 of those, you've walked 1 kilometer. It's just over half a mile. So if we get some practice, like let's just practice getting using these units. So what unit of length would be best to measure the length of a book? Well, if we look up there, I would use the centimeter because, well, it's about the width of your fingernail. It'd come out to about maybe 20 to 30 centimeters, right? That's the appropriate unit to use. What unit of length would be appropriate to measure the distance of a road trip from Indianapolis to Chicago? So if we're driving to Chicago, that's a very long distance. So we'd want that longer one, the kilometer, right? So that'd be like, hey, it's 200 kilometers, right? That's how we would want to measure a road trip. What unit of length would be best to measure the height of this building? So the height of this building, probably want to use meters because it maybe be about 20 meters or so. That'd be the appropriate one. You want to do kilometers are going to be a little too big to measure that, and everything else would be a little too small, right? So centimeters, millimeters, too small. You'd want to use a meter. And the last one is what unit of length would be best to measure the length of an ant? So an ant is very small, so you'd want to use the smallest unit, which is millimeter. You look at an ant and be like, well, that's maybe 5 millimeters long. Then we talked about mass. So when we're measuring mass in the metric system, that refers to the amount of matter in an object. There is a little difference between, well, there's a big difference between mass and weight, but for this part, those can almost be used interchangeably. We will use digital balances to find the mass of objects. Now, the base unit of mass in the metric system is the gram, represented by the lowercase g. 1 gram is about the mass of a dime. So if you think about holding a dime, that's about the mass of 1 gram. Now, a kilogram is about the mass of a filled water bottle. So if you have an Nalgene, that's about the mass of 1 kilogram, or maybe like a textbook. It's a little over, I believe it's a little over 2 pounds. So yeah, that would be 1 kilogram. So what unit of mass would be best to measure the mass of a person? I'd probably use a kilogram, right? So, it'd probably be around 80 or 90 kilograms, right? So, but that'd be an appropriate unit. Now, if you wanted to measure something smaller than a kilogram, like a tennis ball, it'd probably be best to use the gram. And in this class, we're going to be using the gram to measure out these, things that are smaller than a kilogram. All right, so volume. So if we're measuring volume, volume is the amount of space an object takes up. So the base unit of volume in the metric system is the liter. Now in this class, we're going to use the milliliter a lot. So 1/1000th of a liter. Now we're going to be using the graduated cylinders to measure the volume of liquids and other objects. Now there are two ways to find the volume of an object or liquid. So you can calculate it using math or measure using a graduated cylinder. So let's talk about calculating the volume of a regular object. So for calculating the volume in the metric system, we can calculate the volume of a regular object. So if you look over to the right, down at the bottom, there's going to be a bunch of different regular objects. We know the equations for these. Now, in this class, we're only going to focus on the rectangular prism, or the box. And that is with the formula length times width times height. Now, here's the key here. 1 centimeter cubed equals 1 milliliter. So 1 centimeter cubed. So like if you're looking at that rectangular prism, you're multiplying length times width times height. Well, if we're multiplying centimeter by centimeter by centimeter, well, that's centimeter multiplied by itself 3 times, centimeter cubed. Now that is 1/1000th of a liter, or 1 milliliter. If you think back to like a doctor show and they say we need 200 cc's of this medicine stat, well, cc stands for cubic centimeter. They're asking for 200 milliliters of that medicine. So let's get some practice. Let's look at that prism and calculate the volume of it. So it has a length of 3, a width of 2, and a height of 3. So 3 times 2 times 3 is going to be 18 centimeters cubed, or 18 milliliters, right? Remember, those are the same unit. Now, when we're measuring volume, right, when we're measuring liquids, we use a graduated cylinder. So what you do is you read the measurement based on the bottom of that meniscus. When using a real cylinder, make sure you're eye level with the level of the water. So let's get some practice. What is the volume of the water in the graduated cylinder? So let's take a look at these three over here. So this first one, you can look and you can see here that every one of these little dash marks is going to be 1 milliliter, and it's kind of right on 52 milliliters. That would be the first one. Now that middle one, you can see that the scale has changed a little bit. So 35, 36, 37 milliliters. And then over here, well, you can see it's a little bit tricky because now each one of these, they go 5, 10, 15, 20. Each one of these is 2.5. So this one's probably 23 milliliters. So it's all about looking at the resolution of those graduated cylinders. So let's get back to that original question. How can the volume of an irregular object be found? So we learned about rectangular prisms, but what if I have something like a rock? Well, let's take a look at measuring volume, right? So if we measure volume of an irregular object, we use water displacement. So remember, 1 centimeter cubed equals 1 milliliter. So let's just say I want to get the volume of a key. How much space does that key take up? Well, let's just say I have a graduated cylinder, and you can look and you can see that it's filled up to the 50 centimeter cubed mark. So that's 50 milliliters. So before the key is placed in there, it's at 50 centimeters. Now, what is the volume of the water after the key is placed in the graduated cylinder? Well, it's going to be 60 milliliters or 60 centimeters cubed. So think about getting into a bathtub. When you get in a bathtub, well, that water rises. Well, it's the same thing for all objects. You're displacing that object. So now if I want to find out how much space that object takes up, how much water did that object displace, I just subtract them, right? So I take the final amount, 60 minus 50. Well, that is going to be 10 milliliters or 10 centimeters cubed. All right, so we practiced doing a class activity. That was one of those self-grading sheets that practiced all of these. And then we did a measurement lab. And in this lab, what we did was we we used all 5 different measuring devices that we're going to use in this class. So at this time, I'll go ahead and give you the verbal code. It is 212. I say that again, the verbal code is 212. So in this lab, it took you step by step on how to measure time, mass, length, volume, temperature, and we were able to string that together and be able to do that. So that's very good practice. I would recommend watching that video if you did not get a chance to do that or you need help on that. So once again, there is just too much unknown in the universe to take a break from learning. Get out there and question everything.